Hey guys, Mrs. Traver here. We're going to look through our notes on radical expressions. We're leading into section 1.5 where we're solving quadratics of a different way. These quadratics will need to work on simplifying square roots. So we're going to work on some simplifying of square roots. When I say radical expressions, really what that means is square roots, or roots of some sort, I should say. So here's our first law of radical expressions. It's that if you have a few things underneath the square root that are being multiplied, then you can kind of distribute the square root into each of the terms. So let's use that rule, and I'll start off with something that can be factored. We'll factor it into a and b, essentially, and be able to separate out those two. So here's our first example. If I had the square root of 50, I want to try to simplify this term first. All right, so let's look at 50, and we're going to factor this into whatever terms we can inside the radical. So I know 50 is 5 times 10. And I can factor 10 out again. I'm going to factor these out until all I have is prime numbers. So the prime factorization. 10 is 5 times 2. So 50 is 5 times 5 times 2. And I'm done because all of these are prime numbers. So now I'm going to utilize this law here. And if I've got the square root of, let's make this look like 5 squared. That'll make us recognize what's going on here. So if I've got the square root of 5 squared and 2, I can separate it out into a and b. So I can make this be the square root of 5 squared times the square root of 2. And then from here, our simplification takes hold because square root of 5 squared, these are inverse functions of each other. So I've got 5 square root 2. So square root of 50 is equal to 5 root 2. Let's do another one. All right, let's look at 80. So prime factorization of 80, I know that it is 8 times 10, and 8 is 4 times 2. Actually, let's make 8 be 2 times 2 times 2. And 10 is going to be our 5 and our 2. So I've got 2 to the 4th times 5, all under the radical now. 2 to the 4th square rooted times the square root of 5. Let's see, this would be 2 squared 5, or 4 root 5. So we've got root 80 is equal to 4 root 5. Our next law of exponents is similar to the first. So if I have a fraction inside a radical, I can separate that and essentially distribute the radical onto the numerator and denominator separately. So let's run an example like that. If I had the square root of 6 over 25, I can distribute the radical onto the numerator, so root 6 over root 25. The bottom there was just going to simplify to be 5, so that's nice and easy. The top is root 2 times 3. I can't really do anything there, so I'm just going to leave it as root 6 over 5. Let's look at this next one, root 9 over 36. So distribute that in, root 9 over root 36. Root 9 is 3, root 36 is 6, so we've got 1/2 here. My last law is if I have a coefficient out in front of my radicals, then I can kind of factor this out into having xy radical ab. So let's do one like that. So in this one, we've got 3 root 2 times 4 root 5. Based on this, we can take our coefficients that are out front, 3 and 4, and we can take our numbers under the radical and put them under the radical together. So on here, if we reduced, we've got 12 root 10. And that is all we can do there. So there's a few different types of examples on simplifying radicals. We're going to be able to use these when we look for solving equations of quadratics when it doesn't work out to factor. So this will all be used soon.